that has to do with inequalities. And of course, the next logical step to take is to do some word problems that involve both inequalities, and in fact, we're also going to have some more equalities in there. Let's look at this problem that I have written here on the board. It says, find the three smallest consecutive even integers whose sum is greater than 45. So there are two important words here, one of which is consecutive and the other is even. So for example, if 4 is an even number, what is its next consecutive, or what is the consecutive even number? And Chuck says 6. So let's see now, it says here, find the three smallest consecutive even integers whose sum is greater than 45. So do you know what the smallest one is? X. Good. That's fine. So let's let x equal the smallest, what? What can we call it? Smallest even integer. Now notice it's an integer, not a number, because when we speak of even and odd integers, okay, that's exactly what we mean. We don't have 3.5 as an even or an odd number, okay? So if x is the smallest even integer, what is the next consecutive, or what is the consecutive even number there? Ken says
x plus 2.
X plus 2 is the consecutive even integer, okay? And then, of course, what would be the largest even integer that we have here? Sally says
X plus 4.
X plus 4 is the largest even integer, okay? And you look at the sentence, the conditions of the problem, and who thinks that he can write a sentence here, which will give us what we want. Todd says
X
X
plus X plus 2
plus, let's include that in parentheses, X plus 2
plus X plus 4
plus X plus 4, and the sentence, or the statement of the problem that says that this is greater than 45. Everyone agree with that? Okay? And you look at that, and you say, well, let's see, I have 3x plus 6 is greater than 45. Is that right? Okay? And we don't want 6 here, so we end up with what? 3x is greater than 39, and you say x then must be greater than 13. Now, x must be an even integer, and we came up with x is greater than 13. So what's the first smallest even integer? And Barb says 14. So you suspect that the integers are going to be what? 14, 16, and 18. Is that right? Okay. Well, in fact, let me erase these commas, and let's check right here, because what do we want to do but show that this sum is greater than 45? And what does the sum of these three numbers give us? It is what? 48. And indeed, 48 we know is greater than 45. Perhaps there's another check that we should take. Perhaps someone isn't quite convinced that 14 is going to be the smallest one. So let's try, well, maybe we should try what number?
12.
Let's try 12. All right, so let's try 12 plus 14 plus 16. And what does that add up to?
42.
Oh, it only gives us 42, and of course 42 is not greater than 45. So therefore, what is our conclusion? That the three integers, the three, what, even consecutive integers are what? 14, 16, and 18. Okay? Now notice again our 5-step procedure. The first step is to state what our variables are. The second, in this case, we're writing an inequality, a sentence that has to do with an inequality. The third is to solve it. The fourth is to check that statement in relation to the original problem. Right? This is our mathematical model, which we're going to check against the data. And then, of course, we are going to write a sentence which answers the question that is asked. Okay? Let's do the next problem. Here we have the length of a rectangle is twice the width. Well, let's make a little picture here. All right, in which let's say that, let's call this W. Let me use the letter W to refer to, let's try to get a little bit away from the letter X. All right, and W might be another name for the number of, in this case, what? Inches in the width. And of course, if that's W, we're told what? That the length is twice the width. So give me a name for this, what we can write here. Barb says 2W, okay? In fact, let's write down what our variable is. Let's let W be what? The number of what? Inches in the width. Is that right? And hence we can say what? 2W is the number of inches in the length, okay? And now who has a sentence here? It says that the length of a rectangle is twice the width. if the perimeter is not greater than 72 inches. Dave says,
Okay, it would be W plus W plus 2W
plus 2W
plus 2W
plus 2W.
is less than 72.
Let's see, if it says not greater than, let's take that literally. And Brenda says, less than or equal to. Well, if you don't mind, let me write first, not greater than. And give me a symbol that we can use. Todd says,
Greater than symbol with a line.
a greater than symbol with a slash through it, okay? Not greater than 72. And let's clean up the left-hand side, and everybody agrees that this is 6W. And give us another name now for a not greater than symbol that we can write here. Steve says, fine, yes, you're 1 or 2 steps ahead of us. Give us a number, give us a symbol, rather, for this symbol here. Another name for this, not greater than, Sally says, less than or equal to 72. And of course, here you can say W. Steve says W is what? Less than or equal to, is less than or equal to what? What can we say here, Ron? 12, okay? Now, the original question asks, what is the greatest possible width? And our width now is some number which is less than or equal to 12. What's your conclusion from that? And anybody? Kirby says?
Greatest possible width is 12.
The greatest possible width is 12. Let's check that. If we have a greatest possible width of 12, right, we have what? 2 times 12 plus, right? That's for the 2 widths, and the length is what? Twice 12, which is 24, and we have 2 times 24, and the question is this number less than or equal to 72? Or in fact, is it equal to 72? I think you'll all agree that this is yes, and hence our conclusion is what? That the smallest possible, right, width is what? Is what? 12 inches. Is that right? Okay. Again, we have our 5-step procedure that we went through in this case.
Could you do that by an indirect proof, that problem?
By an indirect proof. I think there's something that I wrote here that isn't quite correct. What is that? Chip says the largest possible width, right, rather than the smallest one. If we have here less than or equal to 72, we're talking about the largest or the greatest possible width is 12 inches. And there's a question that was asked, can we do this by an indirect method? Well, for one thing, when we talk about an indirect proof, it's some statement which we're going to prove. And here, in this case, we have a problem which we are trying to solve. And I hope that you can distinguish between a statement which we must prove on the one hand and a problem which we have to solve on the other. And these are really quite 2 different things. So I don't think it's a question that one can ask to be able to do this by an indirect approach, okay? But rather simply to approach it as a problem. Let's go on to the next example. A turboprop plane left Chicago for London at 12 noon, traveling at 330 miles per hour. Okay? At 2 p.m., a jet plane left Chicago for London and traveled at 550 miles per hour. After how many hours did the jet overtake the turboprop? Okay? Now, there is some relation that you, I think, have learned in the past that has to do with distance and rate and time. And does anybody happen to remember any statement about that? Well, for example, if you were traveling, say on the turnpike here, at 60 miles an hour, at an average speed of 60 miles an hour, and you traveled for 2 hours, how far did you go? And Chip says 120 miles. In that case, 120 is equal to the rate, which is 60, times the time, which is 2. Okay? So that in general, if we have a distance, d, all right, it's going to be equal to some rate, which is the number of miles per hour, and we can take an average rate, r, let's decide to call it r, times the number of hours, okay? In this case, let's decide to call it t. Does anyone remember this statement? All right, distance is equal to rate times time. Oh, good, I thought you've never seen it before. Now, let's look at the problem that we have here. If we think of this point here as that point, let's say Chicago, is that where we're starting from? Okay, we're starting from Chicago, and we are going in an easterly direction here from Chicago to London, all right? Now the turboprop plane, this is some distance. Let me use the notation distance, and let me put a little sub p down here for the turboprop. Okay? Now 2 hours later, is that right? 2 hours later, we start at the same point, and now this jet plane starts out here, all right? And at some time, because he's going faster, his rate is 550 miles an hour, all right? And if they continue on and don't run out of fuel or anything else, all right, at some point out there, the distance of the jet plane is going to be the same as the distance of the turboprop. Is that right? Everyone agree with that? Okay? So what's the one relationship that holds true in this problem? What can you say about these two distances? What can we say about the two distances?
They're going the same, to the same destination.
All right, yes, they're going to the same destination, but more importantly, what can we say about the distances of these two planes? And Ken says
They're equal.
they are equal. So let's indicate this by the distance of the turboprop is equal to the distance of the jet. Okay? Let's just indicate it in this fashion right here. And this is the relationship that we're trying to establish. Now, you know that distance is equal to rate times time. So the question is, what is the rate of the turboprop? And what is the rate of the jet? Well, we know that the rate of the turboprop is what? 330, and the rate of the jet is 550. Now, the next question is, what is the time t of the turboprop? Or indeed, the question is, after how many hours does the jet overtake the turboprop? So let's now introduce a variable. Instead of calling it x, let's decide to call it t. All right, what do we want to say that t is? Let's let t equal what? The number of hours. Number of hours. It's always a number of hours of what? When they meet, all right, or when their distance is the same, all right? Number of hours. Well, let's instead of saying when they meet, let's say what? Of jet. All right, of the jet plane, okay? The number of hours that the jet plane travels in order to overtake it, okay? Well, if that's the number of hours for the jet plane, how many hours did the turboprop plane go? Brenda says
T plus 2.
T plus 2. T plus 2 is the number of hours of the turboprop plane, okay? Everybody can understand that, all right? Now, distance is rate times time. So let's talk about the distance of the turboprop, okay? And it's going to be what? Its rate, and how fast does it go? 330 times its time. And what is its time?
T plus 2.
T plus 2. Now that's one number, t plus 2 in parentheses in this fashion. And this is a total distance, must be equal to the distance of the jet. And what then is the distance of the jet? It's his rate times his time, or its, rather. David says
550.
that's 550 times time, okay? Now let's clean this equation up. In fact, rather than multiplying through here, I look at 330 and at 550 and everything here is in the form of multiplication. And give me a number which will divide both of these two numbers. And in fact, the biggest one. 5. Well, yes, 5 will divide it. In fact, I think I find a big number which will divide this. Sally says 10. Well, much bigger than 10. Brenda says 110. I think 110. If 110, what's the factor here? 110 divides 330 how many times? 3 times. All right, so we have here 3 times t plus 2, and 110 will divide 550 how many times? 5. And here we have 5t. And look at this. We have our distributive property, 3t plus 6, is that right? Is equal to 5t. If we subtract 3t, we'll have what? 2t is 6, t then must be 3. Now, let's see if we can't check. All right, if it takes 3 hours for the jet, and it travels at the rate of 550, let me put it in here. All right, it's 3 times 550 must be the same as, let's put a question mark on this, as what? Well, it's what? T is 3, and 3 plus 2 must be 5 times 330. So is this statement correct? 3 times 550 is what number? 16, what? 50. And I think just from the symmetry here you'll agree. And on the right-hand side, 5 times 350. Oh, it's 1650. So sure enough, it checks. Let's write in here, therefore, the The question asked is how many hours did the jet overtake the turboprop plane, and it took what?
5.
Careful. Let's let T is the number of hours for the jet. So it overtook the turboprop in how many hours? 3 hours, okay? Therefore, the jet overtook turbo in, all right, let me just write in here, in 3 hours, okay? And again, I think if you look at this, we can have our 5-step procedure, in which here's our first step, is to state what our variables are. The second step is to write the equation. The third step is to solve that equation. The fourth step over here is to check it. And the fifth step is to come to our conclusion, answer the question that is asked. Okay? Let's look at another example. I have another problem here which has to do with rate and time and distance. The average rate of a new express train is 30 miles per hour faster than that of a freight train. All right? In 5 hours, the express train travels the same distance as the freight train travels in 8 hours. Find the rate of the express train. All right? Now notice in the first problem here, number 3, that had to do with rate, time, and distance. The question had to do with find the number of hours. Find T. In this question, find the rate of the express train. Find, what are we now looking for? R. Okay? And again, the relationship that we are familiar with is that distance is equal to rate times the time. Okay? Now, the average rate of a new express train is 30 miles per hour faster than that of a freight train. Do you know what the, let's say what, the rate of the freight train is? Well, the question is find the rate of the express train. So let's start out here with, what? Let's let R be what? The number of hours, the number of miles per hour of the express train, okay? So let's let R equal the number of miles per hour of the express train. Now, if R is the number of miles per hour of the express train, and it goes 30 miles per hour faster than the freight train, what is the rate of the freight? R minus 30. Everybody agree with that? It is the number of miles per hour of freight. Okay? Now, distance is rate times time. Now, what do we know here? In 5 hours, the express train travels the same distance. So what is the one relationship that holds all of this problem together? What's the one statement that you can say, Todd?
Distance equals distance.
Right, the distance, let's write it this way. The distance of the express train is equal to the distance of the freight train. Is that okay? Now, what then is the distance of the express train travel? We know that distance is rate times time. So, what is its rate? R, and what is its time? 5. Okay, is equal to, now what then is the rate of the freight train? R minus 30, and what is its time? Times 8. Okay, and let's turn the crank on this. We have here 5R. Now let's use our distributive property. 8 times R is 8R minus 8 times 30 is 240. Now watch what I'm going to do. Let's decide to subtract 5R from both sides, and we have 3R. Let's then decide to add 240 to both sides is equal to 240. And 3 will divide 240, and you get what? 80. So let's then turn the thing around, and R is 80. Now, if R is 80, R minus 30 must be 50. Now let's check right here. Let's check. Now let's see. It's what? 80 times 5. The question is that equal to what? 50 times 8. And what is your conclusion about that? We have here what? 8 times 5 is what? 40 times 10, which is 400. It's 400. It checks. Therefore, our conclusion is what? That the express train, what? Traveled what? What's the speed of the express train? Travel at the rate of what? Traveled 80 miles per hour, okay? And that answers the question that is asked. Find the rate of the express train. Again, I think you will see in here our 5-step procedure. Let's look at our last example. Jack was traveling at 24 miles per hour on his motorbike until it broke down. All right? I guess this is what happens to most motorbikes. He left his bike and walked back to his starting point at 4 miles an hour. All right? He arrived 7 hours after he left. So he goes out some distance riding on his bike, all right? And then it breaks down, so he has to walk all the way back. And the total time, you were told, is what? The total time is what? 7 hours. The total time out, all right? So what then can we say? What's one relationship that we can use in order to pull this problem together? The time that he goes out, all right, on his bike, and what else can you say about that? Plus, what? The time that he comes back is equal to 7. Good. So let's then write this in terms of time on his bicycle plus the time on his walking, on his feet, is equal to what? Is equal to 7. 7, just the number 7, okay? The number 7. Well, you and I know that distance is rate times time. Now here I'm using capital T, but our general relationship is this. Give me T equal to something. What's T equal to? If the D equals R times T, what's T equal to? This is one of our little formulas. Is equal to?
D over R.
D over R. Does everyone agree with that? You're simply dividing both sides here by R. Now, all right, now what is the statement here that we are looking for? How far did he travel before his bike broke? So what are we looking for out of D and R and T? What are we now looking for?
Distance.
D, distance. Now, is the distance that he goes out equal to the distance that he comes back?
Yes.
Of course, all right? So, we're looking here for time. The time that he bicycles is distance. Let's let D be the number of miles that he travels, okay? Number of miles traveled, what? On bike, okay? Let's let D be the number of miles that he traveled on the bike. And of course, if that's the number of miles that he traveled on a bike, the number of miles that he walked is the same. Is that correct? Okay? So then what do we want to say here? The distance divided by his rate. Now, it's his rate on his bike. What's his rate that he traveled on his bike? 24. Okay? Plus the distance that he traveled walking divided by that rate, which is 4. And of course, this is time out plus time in is equal to 7. And there's a nice little relationship that we can come up with, an equation, and you look at that equation and you say to yourself, well, I don't want this number 24 here, nor do I want this number 4 here. Let's use our distributive property, and here's D over 24 plus D over 4, and what number can I multiply through here in order to get rid of 24 and 4? 4? All right, 4 times D over 24 is still going to give me some number in the denominator. I'd like to get rid of the denominators completely, and what number can we use to multiply by? Anyone? What do you think? Well, what number times D over 24 gives me 1 down here? And of course, everyone says 24. Is that right? All right. So if I multiply the left-hand side by 24, we have to multiply the right-hand side by 24. Is that right? Okay. Now, 20, let's use our distributive property. This is like A times B plus C. All right? Which is A times B plus A times C. So 24 times D over 24 is D, 1D, fine, plus 24 times D over 4 is 6D, is that right? And this is, let me write this as 7 times 24. And D plus 6D, of course, is 7D is 7 times 24. What number will divide? 7, and hence D then is equal to 24. Oh, look at that. He goes out 24 miles. But he traveled at the rate of 24 miles an hour. All right, so how long did it take him to go out? 1 hour. All right, and hence if he walked back at the rate of 4 miles an hour, and he traveled at the rate of a total distance of 24 hours, how long? 6 hours. So 1 hour plus 6 hours adds up to 7 hours. Does it check?
Yes.
Okay, I think you will agree. Let me just write in here the check of 1 plus 6 is equal to 7. That checks. Therefore, let me write it right in here. Therefore, our conclusion is what? That he bicycled, or he motorcycled, or whatever he's on there, a motorbike. Yeah, he biked. Let me just use that. He biked what? Well, how far did he go? He biked
24 miles.
24 miles, M-I-L-E-S, okay? Now, again, I think you will agree that we have our 5-step procedure in here, in which here is our variable, here is our sentence, we have solved that sentence, we have checked it, and hence we have come to our conclusion, and we've answered the question that was asked. Okay? Notice, in these 3 rate distance problems, this problem had to do with time. This problem had to do with, as we had to find the number of hours, this problem had to do with finding the number of miles per hour, the rate, and finally the third problem that we did here had to do with the rate and time, asked for the distance. We found its distance. Okay, let me give you your assignment for next time, and I think that's all we need to do. This will be assignment